Okay, this should be live. And hopefully I have the audio on this time. Move this over there. Yeah. Welcome to whoever joined. Apparently there's 2 people here now. Solitude. Oh, hi. Yeah. So, for those of you who have seen this or seen my previous videos, I have now created this repository on GitHub. So I've given the keyboard firmware project a name. It's called Badger. And for now I'm just using the NIM mascot with a crown as a sort of logo of sorts. Yeah. So one thing I do say here that this is I think I say here yeah, entirely from scratch in NIM. But the repository is still 68% C code because of this USB stuff. So we should probably rewrite that at some point, the USB stuff. But today we are going to do layouts, and we are going to have a look at sort of the memory, how memory is handled in Arduino. So I did some things here. I created the repository. I have tagged each of the sort of episodes I've been doing. These are the ones that you can see on YouTube. I have released the first edited video, which links to both to like this Twitch channel and the repository, but also to the unedited video. And the unedited video also lists to a playlist of the unedited videos. So here you have all of the unedited ones. I have edited the second one. I'm going to render that out and release it after we're done here. And I'm almost done with the third one. I have also set up stuff, some keyboard shortcuts and some like recording of when I switch the scenes and when people say something on Twitch. And I also have a button I can hit in order to record sort of events that I might want to cut out, which would make this a lot easier. Or make these a lot easier and a lot faster to edit. So hopefully they will be, I won't have to spend as much time editing these videos, and I can spend my time actually writing the keyboard firmware instead. So, with all that out of the way, I'm not sure if anyone's even watching at the moment. Doesn't look like it. The view count says 1. Yeah, anyways. So, at the end of if you don't remember, if we look at what we had after chapter 2, so the second episode I did, what we had here was we were using a lot of program memory because we were using this each it macro that just expanded, basically unrolled this loop on compile time, which creates a lot of code. Oh, hi. Welcome. And then for the second episode, or no, the third episode, we wrote a smarter macro to. So we wrote this with pin as. We also wrote this configure, but also this with pin as thing. And basically what that allowed us to do was to cut down the size of our program. So as you can see here, it took 2,966 bytes. We cut that down to 2,004 bytes, so almost a third of the program. But this increased, the data increased. As you can see, it was 13 bytes, now it's 25 bytes. And at the end of last time, I was like, I'm not quite sure where these come from, like what happened here, what created these extra bytes. So I did a little bit of digging, and I created a new target in our makefile. This size breakdown target. Basically what it does is that it looks at the file and it lists out all of the symbols in the different sections and their sizes. So as you can see, the data section, which is where we got more bytes, consists of, so data is in both of them. But yeah, we have data and we have BSS, and this has increased to 25 from 13 bytes. And if we look at this, we can see everything that lights were blinking. We can see everything that we expect. So these things are from the USB stuff. These ones are from the USB stuff. So you can't really get rid of them. Not that we would want to. And these ones are the letters to print out for each key and each row. So these things. But so none of that looks weird. That all looks fine. And if we just copy this target, and we check out chapter 2, and we, oh, I did something dumb there. Let's see. Git checkout master, open this make file, copy this. No. Copy this, don't close it. Check out chapter 2. And if we have a look, if you open this, just foreground that one, we load the file. We paste in what we had copied out earlier. Now we just have to update. Oh, I can do this faster with this. So I renamed the entire project to Badger. So if we look at this one, so this one is the one that weren't using as many bytes. And what we can see is that our definitions for those keys has gone. These column keys and row keys are now gone from our data section. But curiously, if we have a look in the cache for this, in here, they are still here. So this column keys and the row keys, they are still here. So what's going on? How can they disappear from our program but still be in our generated C file. So as I mentioned, this thing actually unrolls our loop on compile time. So if you have a look at the source code here, this each it unrolls this loop on compile time. What that means is that in here, we have a lot of code for the unrolled loops. And you can see these are accessed many times with this column. And the column is increasing, it increases once per sort of unrolled iteration. And the thing is that GCC is smart enough to see that these are always accessed by static variables. So it is actually able to unpack just the values of this directly into our program, which is pretty clever. So that's, but it obviously isn't able to do that. It obviously isn't able to do that when we don't unroll the loop anymore. Then it needs to actually store these on runtime. But what does this mean? So for those of you who aren't familiar with the memory on Arduino microcontrollers, basically you have a couple types of memory. You have RAM, which is sort of the same kind of RAM that you have in your computer, and you have ROM, which is more similar to what on a normal computer would be like the hard drive. So in RAM we have SRAM and we have DRAM, which are volatile, which means that when we unplug the power, it disappears. Same as with the RAM on your computer. We typically don't have DRAM on these microcontrollers. Most of the time we only have SRAM, which is the same as the caches in your CPU uses. It has SRAM, but the RAM sticks that you insert into your computer, that is DRAM. And that it basically just means, the D means that it's dynamic. It needs to be refreshed in order to stay alive. So it uses power to refresh. While SRAM is static, it doesn't need power to refresh, and it's smaller, but it's typically more expensive. Which is why these microcontrollers and your cache on your CPU doesn't have as much of it. So this chip, I believe, has about 2.5 kilobytes of SRAM. So we have 2.5 kilobytes of memory, so RAM. Now on the ROM side, we have flash, and this is non-volatile. So this, when we power off and power on the chip, this will stay locked in. So flash, that is where our program lives. That is where the program and everything that we will put into SRAM, we'll look at that in a second, that is where all of this stuff goes. And that is what you can see if we do make size. We can see that this is text plus data plus the bootloader, 2004 bytes. So this microcontroller has about 32 kilobytes, I think, of flash. But we can't write to this on runtime. EEPROM is non-volatile storage where we can write stuff. So if we wanted to save something from one run and then unplug and replug and have stored something, we would save it in EEPROM. So for example, if we had set it up with a password to access something, or if we had, so for a game, for example, we might want to have high scores, stuff like that, that we would store in EEPROM, or a save game for that matter. That would be stored in EEPROM so that the next time we power on the game, it would still be available to us. For the time being, we're not going to be using EEPROM for this project, so we are mostly looking at Flash and SRAM. So, you might have seen when I did the size breakdown, you might have seen this data section, BSS section, and text section. So data is data plus BSS. I'm not quite sure what no init is, because BSS is uninitialized. And program is text, data, and bootloader. So why is data here twice? Basically, data is all of our variables that are initialized, that have some kind of value. So in our case, that is the keyboard idle configuration, apparently the keyboard protocol, these are from the keyboards things, and then the data that we have entered into our program, these column keys and row keys. But for example, the keys that we have currently pressed and the modifier keys, that is stuff that is going to live in memory, but we don't have an initial value for them, so they are just going to be 0. So we don't need to store a value for them in our program. We just store, yeah, this one is 6 bytes long. This is 1 byte long. So we just store, it probably just stores that it needs 11 bytes for all of these. So it will take these. What is that? This is 14 bytes. So it takes these 14 bytes, copies that from Flash. Then it allocates these bytes in this section. And then we can do heap memory. So that is if we do a malloc, we do heap memory. And then the stack, so we start our program, and for every stack frame, we grow our stack upwards and of course back down. So this stack will vary up and down. This is very much like your computer operates. Yeah. So as you can see, the problem here is that these live in memory, like they just stay there for the entire duration of our program, and we're quite limited in memory space. As I said, we have about 2 kilobytes or 2.5 kilobytes of memory or RAM in total. We don't have external RAM, so you can connect an external RAM chip to a microcontroller, and then you can have more memory. We don't have that, so we just have this. So we really want to keep our data low so that we have room for our stack and our heap, and we don't want to fill this up too much. I mean, we can have some stuff here, but we don't want to fill it up too much. So what we can do in order to not fill this up, and if we look in the USB keyboard stuff here, and I had to do some debugging on these because this is outdated, or the library that shipped with us was outdated. You can see they use this progmem pragma here. So these are global variables. They are quite big, but they have this progmem thing attached to them. And what that does is that it moves them into, why does that light keep blinking? It moves, so the progmem, we can use this to store data in flash, or also called program memory, instead of SRAM. That means that we store it right next to our code instead of storing it in memory. But in order to get it out of SRAM, we have to use this PGM space library, which has PGM read byte or read float and word and all of these, along with like memory copy and string compare, so you can compare a string to something that is in program memory. A lot of stuff like that. So we are probably going to use this PGM read byte the most. It uses the near version. Near just means that it's in the first 64 kilobytes of memory. Oops. Or program memory. We don't have more than 64 bytes, kilobytes, so that like we will never need the far ones unless we connect external RAM. And you can see this one just calls this __ LPM, and essentially all that does is called LPM enhanced. All LPM enhanced does is it's a wrapper for a special CPU command to load program memory. So this is a special CPU symbol to load program memory into our actual memory. So yeah, so we're going to be wrapping the things that we need from this AVR PGM space. And we are going to move some of our stuff into memspace, because when we start doing layouts, if we have a lot of layouts or if we have big layouts, that would take up a lot of memory that we might not want to use for just holding that information. Layouts probably aren't going to take up a lot of room, so we can play around with not having them in program memory, but we'll see. So, if we let's create a new file here, call it pgmspace.nym, and have a look at what we did for the keyboard one. Oh, actually not the keyboard one, because that's a local file. So we're going to be doing, this. So this we are going to load from the PGM space thing, and we are let's just grab this one to begin with. So is it that, and this doesn't have highlighting for some reason. Just gonna open that again. I know I can just reload, but I can't remember how. PGM read byte, address. This is a pointer to a uint8 for now, and it returns a uint8, or it returns a byte. And we are going to import this from C. It's going to be called PGM read byte. And that should be all we need. Oh, and we need to export this, of course. And that should be all we need to read stuff from program memory. But we can't just go around and attach C pragmas to stuff like this. So we need to do some tricks here. So what we are going to use is what's called CodeGenDecl. And we are going to hide this away in a second. What CodeGenDecl does is basically it tells NIM, hey, you know the code you wanted to generate for this statement. Don't generate that, generate this code instead. And I did find a bug in this recently, but it won't stop us from doing what we need to do. So basically what this does, nlib private, that just is that's a nim thing. It says make this a private thing for nim library. Constant, because they have to be constant. This one is the name, I believe, and this one is the type. And the type is going to be, so the nim is going to know what the type is. Oh, and we can't have that as a const when it's program. When it's CodeGenDecl. CodeGenDecl doesn't work with const. Just move this here as well. It won't matter for us. So now if we, so this won't work. Ooh, I didn't like that. So it almost seems like it didn't include, oh, we need to import this. That might work. I think we might have to use something from that module in order for it to actually load this header. So when we hide away this thing, basically that error means that it doesn't know what progmem is, because progmem is from AVR PGM space, and it wasn't loading that. So what we now need to do, we can't do this. We can't do column keys and just access the row. We need to do the PGM read byte, and that is going to be cast this to a pointer to a uint 8. And that is going to be column keys dot address. Does that have an address? Yes, it does. What is this complaining about? Oh. There. It doesn't have an address because it's defined as a let. We don't want anyone in nim land to try and edit this because it's not possible to edit these. So we have defined it as a let, but let technically might not have a pointer. So that's why it has unsafe address, but it's safe in this case. So that gives us the first one. We are going to grab the address of this one, which should be correct. Yep, I managed to build that. And if we look in our cache here, we should see, yeah, we're including the PGM space library. This array right here is now, I guess we could have used nym_const instead of const. It now, yeah, it's the same type. It's a type of 5 unsigned integers, but it now has this progmem thing attached to it, which should store it in program memory. And if we look down here, it's calling the pgm read byte function. If you have a look at the size, we can now see that the size of our code went, or our data section went down to 21 bytes. And I believe, yeah, so our program size went up a little bit because it now has the load this from sort of disk, or load this from the flash memory instructions in there. So we added 2 bytes to that, but we took 4 bytes off of this. It should have taken 5 bytes. That's a bit strange, because that is it has 5 bytes, that array. That's curious. Hi, we're doing keyboard development, writing keyboard firmware in Nym for my own very custom keyboard. So why did that not save us 5 bytes? Only 4. I'm curious. So I just want to have a look at the size breakdown. Not that it matters terribly much, but so this is 25, 1157, 111116, and this 1116, 117. So it is 5 bytes, which should have disappeared. But it's only 4. Curious. It might be alignment, because 7, 8, 9, it might align to 16 bits things. Let's try just for fun. So let's go back to this. If it's alignment, then adding a little, but we would need to use that as well. Yeah, it doesn't really matter. So yeah, saved a little bit of RAM, moved that into program space, and of course to check that it works. Let me switch to the chip cam. So if I now hit the reset switch, it's rebooting the microcontroller, and it is still printing out all of our keys correctly, which is good. So that works just as we would expect. So now we can grab this and attach it to here, and we can do the same thing down here. Dot unsafe address there. Look at the sizes again. We have now saved even more, 13 bytes. And oh, this is actually down to 2004 from 2006. So it was able to do some kind of optimization there, it seems. But yeah. Of course, let's double check that this works. I mean, it's no help in optimizing stuff if it doesn't work. Okay, that worked fine. So this obviously looks hideous. We don't want to do this code gen decal stuff. I guess I can do nim-const for these. Was it nim-const they were called? Or is it just n-const? No, I obviously don't have any constants anymore. I'm gonna guess n. Nope. Him? Yeah. Okay. And just again to double check that everything works. Yep. That works fine. So we obviously don't want to have this. We don't want to have these pgm read byte things in our code. It looks ugly. So we are going to add some more macro magic here. But before we do that, have you also tried using LTO? Yes. So if you look at the make file, not the make file, the CFG file, I'm pretty sure this does. Oh, it actually doesn't. I thought it had FLTO turned on. I don't think it's right. I don't think it should matter. Oh, wow. That actually saved us like 20, almost 20 bytes. Double check that works. So the all the flags I have for this are basically just copied from the sort of official TNC thing. Oh, seems to work fine. Cool. It's weird though that they hadn't enabled that by default. Right, this blinking light is driving me nuts. I think I might know why. So I have my home. So these are remote controllable lights, and I have written some code in Nim actually that dims them down in the evening, so that it slowly goes darker in the evening. I think that might be why they're blinking for some reason. Oh yeah, I can see them if I open the Twitch chat. And today I actually have that open in a separate tab. on my other monitor. So today I can't see them. But normally I just read the ticker on top of the screen. So I started with before we do that, let's have a look at something like this, but I'm not sure I want to do that right away. Not really this one either. So in this one, so this is a constant, and like this is how you would do it in C. It's just a bunch of numbers, and these takes uint 8. I kinda want to make it more type safe, and in Nim we can add type abstractions even though we import it from C code. So I was thinking of adding of making these a bit more type safe, making these enums, doing all of that good stuff. No. Well, yes, they do have the same, because these are modifiers. And these are keys, which are two separate things in sort of keyboard USB specification. But here you can see both key and modifier take a uint 8. So we could, in theory, by accident, pass this into here and get an error. Or get undefined or defined behavior, but not the behavior that we would want. So we can do this, and we can do... This is an O-ring of... Oh, that's good. I mean, I have a pretty fast connection. And I'm on fiber optic connection, so it should be fast, but... So let's actually not export this. It should be a 200 connection. Oops. I mean, now I'm streaming, but yeah, it's a 200 connection. So we are going to write a... okay. Let's not do that. This is a key. This is modifiers. And we're going to make a type block here. Key is a distinct uint 8. Modifiers is a distinct uint 8. And then or x, y modifiers. Just borrow that from the uint 8 definition. Then grab the, oops. Oh, they're not going to be distinct uint 8. This is going to be an enum. I'm going to grab all of these. There. What? There, just indent that. these stars, because we are exporting the type itself. We don't have to export all of the fields. Well, let's stick to 80 characters. There is a way to hard set the size of this. I think it's something like this. Okay, so I am going to replace all U8 with or all U8 new lines with a comma space. That didn't work because I didn't have new line correctly. So in Vim, for some weird reason, this isn't a new line. I think it's this one for line feed. No. That is so annoying. Some of these don't even have the U8 thing. So we don't really have to define a value for all of these because they are going to be sequential. I just wanted to make sure that I didn't by accident have a hole in this and mess it up somehow. So if I had a hole in the sequence here, then that would just mess it all up. I don't think there is one though. But I know that this list is not it's not this isn't the full list of keys. And I mean, these are the key codes for these keys on a Dvorak, on a QWERTY keyboard. So we probably want to add some kind of functionality to be able to load alternative specifications when we want to define our layouts later on. And now that I say that, I think this might actually be a bad idea. Well, it shouldn't be too bad. Okay, I'm gonna look up the you see, I've googled this before. Backslash R, that's what I was doing. So if I want to replace the end of the string with comma space, that works, right? Yeah. But if I want, wait, do I need to do, no. Well, if we do that, comma space backslash new line with just comma space, trailing characters. I don't know. Almost there. Of course, that one didn't fit in. Okay, and modifiers should also be an enum of size 1. So that is 1 byte. And that's going to be this one right here. We obviously can't use the oops. You obviously can't use the borrow thing that I just did. This is going to be exported. None of these are going to be exported. In general, or just right now? What I'm programming here is keyboard firmware for my custom keyboard. What I'm doing right now is I'm wrapping the I'm redoing how we wrap the simple USB keyboard sample code. And to be quite honest, I'm not sure why, because we are going to be replacing this. I just wanted to show off how we can make, how Nim can make code like this more type safe, even though it is from C. There. Yeah, I have my here is one keyboard half, which uses the TNC 2.0 microcontroller. It's a custom soldered mesh of Kyle low profile switches. And the second half has a IO expander or IO extender or whatever they're called, which speaks I2C, but we haven't wired that up yet. So enough of this nonsense. Oh, and we don't have a 0. Yeah, two halves. It's going to be one keyboard. I am going to create a key none here. So this is going to be key none. Yeah, that was the idea. And it doesn't like this. see. I know we can attach the size on these. I just don't remember how. Bit size? No. That's not the one. Enums in them will try to use the smallest one anyways. Smallest size. So this should be using a uint 8 or a int 8 possibly. Nothing more crazy than that. Invalid order because key shift and key left shift are the same. Damn it. Yeah, I see what you were saying. Well, of course there is. This should be key shift, and this should be key alt. Also need one called GUI. Not quite sure what the GUI key is. That meta? I think so. There. Does this work? No. Because wait, what? Oh. Line 29. And of course, this one, just do that. Pointer to something, read something. Oops. Oh, this needs to go there. And this casting need to cast actually this shouldn't need a cast, I think. There. Okay, so let's switch back to here. Make sure that our refactor here works. Yeah, seems to work fine. And as you can see, same amount of bytes. No overhead in program memory size. But our program is now more type safe than it was before, because this one can now only take keys and modifiers, and we can only combine modifiers with other modifiers, and we can't can't, like before, for example, we could have written key space here and key, I don't know, shift here, for example. But we can't do that now because they are different types, even though they are the same sort of storage type. They're different types, but they're the same sort of data storage type. Of course, this pgm read byte doesn't check that t is a size of byte. I'm not sure if we can do that anyway. We could put it in a template, but we're gonna hide this away soon anyways, so we're not gonna bother with that. So let's make this a bit nicer. Basically what we want to do, let's say we remove or we replace this like that. We write a macro called progmem, which could then do this code gen decal part for us. That would be pretty nice. So let's start with that. Of course, this needs to import macros. This macro progmem definitions. Actually, this can be. Ooh, it can't be typed. That might be an issue. Not right now, but so we want to make a let section, right? I am just going to import macros in here real quick, and we're going to do a dump tree. Actually, let's not do it in there. Let's grab this, and let's just do a dump tree in here, just to see what this actually outputs. Right. So it's a let section, which is full of identdefs with a pragma expression, which has row keys, and the pragma is this thing, and no specific type, and a bracket of keys. So the bug I discovered earlier, this has to be a bracket. We can't wrap this in anything, otherwise it generates weird code, or code that just doesn't work. I have filed an issue with this, but I don't think it has been resolved yet. But yeah, so we need to create this. Of course, what we get in, we can up that up here. Let's, for the time being, just say that this is a new statement list, and let's echo out definitions. And let's progmem this. This is gonna create an error. Oh, of course, need to export this like so. And this is obviously not gonna be doing, oops, not gonna be doing this. Right, so we get assignments from an indent to a bracket. So we need to grab this one and put it in there. and we need to grab this one and put it in there. Right. So let me do this. So this is actually something that I wrote that I got added into the compiler or the macro module. It outputs the code needed to generate a specific tree. So for assignment or for definition in definitions, oops, there. Why did it undercase or downcase the whole thing? Not quite sure what that is all about. This is definition to that. These are the assignments that we looked at earlier. This is that bracket. So this is going to be definition 1. And echo out result.wrapper. What is the issue there? New tree and an array. Oh, of course. It returns something. Right. So this is the output of that, which looks pretty darn much like the like what we had here. So I think this should actually just work as is. This obviously isn't the prettiest thing in the world. We could probably tidy this up a bit. I'm not entirely sure how. Let's just keep it like this for now. Of course, don't echo out that thing. We can get rid of this ASTgen stuff. Let's just double check that this works. There we go. Yep. Seems to work fine. So now this has created these things for us, but we still need to call pgm read byte to get the data out of them, which I don't know. I don't like it. I want to be able to have the same code that we had earlier. So for that, we need to create a new type in here. And we are just going to call it progmem_t. And this is going to be distinct t, I guess. Distinct t. So we want to, and this is where Right. So we have created this distinct t, which distinct just means that we have now created a type that we can't mix with other t's, which makes sense because we need to access them in a special way. Now we need to define this as being progmem. So this is the type field, and I don't think so I'm pretty sure we can't do I'm pretty sure we can't do this. Oops. Oh. So I'm going to add this here as well, so that changing that triggers a rewrite or a refactor or rebuild. Right, yeah. We got an array but expected progmem. Would this work if it's not distinct? No. Yeah, as you can see, that's not great. So it defines it as progmem, but it doesn't have the type there properly. Could we do, I wonder, oops. Could we do this? So type of that should have given me that array. Yeah, expected this. So that is the distinct at work. If we remove this, I think it should work. Yeah. This is the annoying part about that error. Otherwise, we would have just been able to say progmem and then just wrap this thing. But because of that code generation error, we can't do that. So this should still work because we haven't really changed anything. Yeah. That worked fine. So yeah, if we do this and we say new empty nodes, we don't define a type and do sort of what we normally would have done to cast a type like that, and then just do data like this. If we make this, so you see it's happy just having that as progmem. Now we can even do this as a distinct because we are doing that. Right, yeah. We are doing this cast, so it happily defines these as progmem. Of course, now they're distinct, so we can't. What it's complaining about there is this. So call keys here is progmem, and this thing wouldn't be allowed. But that is actually what we want, because what we want to write is something like this, where our data here, for example, is progmem array n t, for example. Export that and have n and t, and that should return us a t, and this should be pgm read byte of, just casts this to array n of t, data, and of course index is an int, index, unsafe address, like that. And now we could do something like this. So this is now this function, and this function reads or takes this data, which we have defined as some kind of program with an array. And I don't know, can we do something like, I think there's a way to define that this has to be a certain size. Of course, this could be a template, but I think C should be smart enough to inline that. Oh. Expression has no address. I mean, I know that it does, but this can't be var. Why am I not able to get that address? Because this would be the same type as before. This would be that same data type as we had before. So this would be seen as an array. Unsafe address. I'm not super happy that that didn't work. There we got the C compiler to generate, or the nim compiler to generate bad code. Fun. To be honest, I'm not entirely sure why that doesn't work. I mean, this won't work like this anyways, but for completely unrelated issues. And it didn't work as a template either. Because it thinks this doesn't have any. Huh. I mean, obviously it has an address. I'm guessing it's because Nim isn't able to see that this is something that would have an address. But yeah, as I said, anyways, this won't work. This won't generate good code because of that bug I was talking about. So we can't really do it this way anyways. I wonder if we don't make this distinct, will this create the same error? Cannot instantiate n. That's curious. I mean, since this is a template, we can't just do this. Ooh, template instantiation to nested. So this needs to do this. I believe. Right. Didn't like that at all. I mean, it's because of this indexing thing. If we do this, just get the unsafe address of the data itself, cast this to an int, add on the index, because these are bytes, so it's just going to be add 1, and then cast this as a pointer to a key, because that's, in this specific case, is what we have. Cast that shape t because we're not using it anymore. We managed to crash the nim compiler. Fun. Well, guess that's what a pointer on these are. Output. What? Required type is a static pin, but expression is of type key. Where does it think we're doing that? What? Oh, for goodness sake. Right. I was just gonna show something silly. I wasn't. This isn't supposed to be this hard. What on earth is this number? It's supposed to be like somewhere between 0 and 7. And why is this a compile time error? I am super confused. Yeah, anyway, so this this doesn't work. That must be like this, and this must be like so. This must go, and this must be program type of data for it to generate the correct C code at least. That creates, so that creates this, which is a program of whatever type of this thing is. And then doing this on data that is a program, which is an array from n to t with an index, which is an int, should return a t. That is a PGM read byte on the address. I wasn't able to cast this to an int. Why not? Why is it trying to do this on compile time? It shouldn't do this on compile time. I am super confused right now. So why do we get this error? This is the nim compiler trying to access an int val of an internal node. But this shouldn't be an internal node. Yeah, it might just be a bug. And this is gonna give us that crazy recursion. No. This gives us cannot be cast to pointer pin. Why would it be cast to a pointer pin? These are pins. These aren't pins. Is that because this is not distinct? Right. So because it's not distinct. It sees this as compatible with the progmem type. Which means that this is matched in this code when it tries to read pins out of the array. So we need this to be distinct. So we need to find a way to hack around this error or this bug. So let me just see if I can trigger this bug for you. So this won't work because we got this, but it expected. So we say that progmem should be, or we say that this variable should be this thing, but we're feeding it something that it's not. But if we do this and say that data should be progmem, yeah, now we have that error. I am just going to quickly cast this to an array of columns that is 5 keys. And PGM read byte. Does this work? Yeah, now I got the expression has no address error again. Okay, so just for the time being, let's not do these. I just want to show you the generated C code error. Why on earth does it do that? Like, why is that an error? Ah, because we're not using PGM read byte anywhere right now. Let me just define this. Why is this giving me so much headache? There was some talk at some point about doing these in a different, or sort of allowing progmem in a different way. Unsafe address, and then use this PGM read byte. That way progmem is included in our program and it doesn't trigger this error. So now, and this will be good because now we have one that is defined and should work, and this one, which we have defined to look like this, which wraps it in this progmem type with this progmem thing here. So if we now look at the code generated for this, we're going to see something interesting. We are going to see column keys. Oops. Column keys right here, which is defined as an array. Yeah, now these are the enum types. So it's defined as an array, which is fine. But our row keys are not defined as an array, or yeah, as an yeah, whatever this thing is, an array. It's not defined like that. It's defined as the array type, but it also creates this temp variable with the content that we want. And what you will see is that it also generates in nim main module, it generates in nim copy mem from or to this variable from this temporary variable. So for some reason, nim has decided that it would be a bad idea to put this data in a global variable, just like it's doing here, and it's then declaring it twice with the same type, so it uses twice as much program memory, and then copy it into there on runtime. And this is not just a bug in this kind of code. This, I tested this. In my testing, I tested this with just normal nim code, and it happens there as well. So, and I found the specific commit that started this issue, because back when I was doing my Arduino or Arduboy programming, I was using this trick just fine, and it worked just fine. But now it doesn't work anymore because nim has it is supposed to optimize something else, but it applies to this by accident, and it's so this doesn't work because this we can't even do this copy. We can't copy stuff into program at runtime. And this is, by the way, this is still the case on the latest dev version of nim. It still has the same error or the same bug. As you can see, this one, it has the copy mem from this temporary variable. So we can't create it like this, because this needs to be a bracket. That is the condition that triggers this, is that what you define here must be a bracket. It's super dumb. So we kind of need to have this here, which means that we can't have it distinct. I guess we could try to write a converter. I mean, this would break with the whole sort of concept of it, but we can try just to see if we can work around this bug right now. Maybe this will work. Type mismatch got program any for program T. Line 6. So yeah, I'm just sort of trying to quiet the bug right now, so that, like, I mean, I hope it's eventually gonna be fixed, but and I can't revert to that older version because it didn't have for loop macros, which we used in the last episode. Now, why isn't this working? Got program any for program T, but expected. Oh. We need to do that. There. Okay. Let's have a look at the C code here. Nope. Still. Ah. Damn it. It didn't inline the thing properly. God damn it. So that doesn't work. How can we... I mean, I could grab, like I could edit my compiler, the nim compiler, like patch it, create a patch version for this, and hope that it's gonna be fixed. Wait, this one. So the issue that I have, that I've created is, where did it go? Here. So yeah, when you have anything like this, it's yeah, in 1.4.0 it generated this, but in 1.4.2 it generates this, the temporary variable and the copy. And here's my bisect script, and this is the... So I could revert this in sort of a test compiler, create a test, like create my own test compiler for this and hope that it's going to be fixed soon. Otherwise, we have to do something else clever. I mean, we could separate this, possibly. Maybe we can... I'm going to try something here. So I'm just going to create a dummy field that we're not really going to use. And like that. Right, it's unable to upconvert that. That's annoying. I was just trying, so basically what I was doing in my original stuff for the Arduboy was I was creating a special type called sprite, which had the sort of it knew on compile time how big the sprite was and such, but it didn't leak that into runtime. And that worked. But the way I created that type was obviously with the wrapping of this bit, which doesn't work in the current compiler. You know what? We're just gonna patch the compiler. Projects, nim, get checkout. let's check out the 1.4.2 version, and we are going to create our own branch. Just call it progmemfix, and we are going to revert, or we're not going to revert this whole thing, but we're going to edit this line in compiler trees there, to 14. So this thing, we are going to turn that back to what it was. Equals nksim. Yeah, that's what it was. And now run I guess it's this. So just build a new nim compiler. So hopefully this bug or this issue will get fixed. And this was even backported into older versions. I'm not entirely sure. So it fixes this, which is actually another error that I have run into before. But I don't think the fix is good. I think this does something weird. So it needs to be nk bracket or nk curly or nk par or nk tuple constructor or object constructor. Could we somehow look like one of those? Wait, we already look like a object constructor. We're gonna have our own compiler soon. So this is riveting, watching the compiler compile. Oh, there is a Twitch emoticon with who made that? The one with sort of attacking badger with a crown. Where'd you get that from? Never seen that one before. I mean the logo that I made, this one I made for NimConf, just because some people really don't like the badger. So I was just trying to tease people with the badger. So this is just basically the cut out head of the original badger logo. But wait, did you draw it from scratch? Or is that like a SVG badger attacking thing that you found and edited? I mean, it is quite small. Still pretty good though. Our nim compiler is done. So now we should be able to do don't do this. Don't really have to do that either, but we'll leave it in there for now. Right. data. There. And if we now have a look at, wait, which version did I grab? Oh, I grabbed 142. I meant to grab 144. Oh well. Hopefully nothing we were using in 1.4. Right. So now this is defined correctly. Row keys and column keys are defined the same without that stupid copy thing down here. Good. And it is distinct, so it won't. This should now be possible, I believe. If this is the version that worked. That looks good. Oh, we actually need to try and use that. So doing this should now either trigger an error or work. Triggers an error. But yeah, now this is calling this and nothing else is calling this, which is good news for us. We are going to cast array and t data and then index that and unsafe adder. I think this is the thing that gave us expression has no address. I sometimes type a keyboard shortcut in my Vim that I'm not sure what it's doing. Yeah, this says expression has no address. I mean, we know that it does. We can do this, I believe. This should always read the first one. Right. Right. PGM read byte. This is a pointer to array nt. Grab the address of that. Now we should be able to cast this to an int. We should be able to add on the index. And we should be able to cast this as a pointer to t. Why? Data.unsafe adder. That should be the address of our array. Cast that to an integer. Add on the index. Cast that to a pointer to a key. Send that into PGM read byte. And it's row keys that So why does it generate this code? It's like it doesn't do this. Let's try and do this. Just to see what happens. Now that got an array of keys and modifiers, which obviously is not correct. Pointer, let's just hard code this to be a pointer to a key. Ah. Got key, but expected array of 6 keys. Oh. Why? Why does it generate this like this? The wrong way around. Like it's not even it's not even doing our PGM read byte for this. Even though we explicitly say that it should. Oops. That worked somehow. Okay. I'm not sure if the code works, but okay, let's see if this works. Chipcam. Let's reset this or reboot. Yep, seems to work. Cool. This, strictly speaking, can just be a new empty node. It doesn't have to be that fancy type anymore. Right, so now we can grab our column keys and put those into there. And column keys can also be read like this. Right, this should obviously not have this attached to it still. Yep. But this isn't great because this is now like hard coded to use keys. And obviously not everything we put into program is necessarily going to be keys. But we are slowly inching closer to what we were trying to do. I am tempted to try something like this. I mean, this is a template, so we don't really have to specify a return type. PGM read byte cast T. So that should cast it to the array thing. And then grab this. This is what gave us the thing doesn't have an address. Yeah, expression has no address. Which is weird, because this is exactly what we were doing earlier, right? Cast. So let's try to read rows, or let's try to read columns. So that would be an array of 5 keys. Column keys. Grab the index, unsafe address, key none. Expression has no address. But this is exactly what we had, no? With the CodeGen decal. There. CodeGen decal like that. Oh, don't divide it like that. And now this thing worked, right? Oh, this obviously is call. Yeah. Yeah, this works fine. But declaring this as progmem of the same thing and then casting it out to the base type. Now it all of a sudden doesn't have an address. That is annoying. I mean, it obviously does have an address. Oh. That seems to have worked. So look. Yeah, that looks good. Okay, let's try that then. See if that will work. So don't cast it, but just do this. Is it working? PGM read bytes of column, that does look good. And these are declared as progmem. Ah, okay. Good night. My sleep cycle is all kinds of messed up. So I'm not going to sleep anytime soon. Yeah, so just remove this unused keyboard import. And let's try to upload this. It works. Okay, great. Yeah, so to get that to work, we only needed to patch the compiler. To patch the compiler and do some other stuff. I will try monkey type when I have a full keyboard. I mean, this one only has 35 keys. So it would have to have a really stupid layout. Right. So this, yeah. I still want to have a way of checking that these are byte size. If that makes sense, because this only reads 1 byte. So if I now, oh, sorry. If we had defined these, I mean, if we define one that overflows this into a uint16, then we're going to have a bad time because it's only going to read 1 byte. But for now, this should work fine as long as we only store, stuff with byte length 1. Right. And this pgm read byte. Yeah, so this really only works on arrays at the moment. Should probably define this to only accept array types. Oh. Yeah. So that's works fine. We can also write a converter from, ooh, I wonder what happens with that. If you write a converter, let's just call it read, t theta is progmem t, and it converts it to t, and it should do pgm read byte cast data. So data.unsafe adder, cast this to pointer to t. There. So that should hopefully have not changed this code. pgm read byte, yeah, that's fine. Basically what this allows me to do is I can now say in this converter, if I can now have a progmem that is just 1 byte. We could, of course, do like a big when statement, when size of t is 1, do this, when it's 2, do the other thing, when it's more, it needs to do, oops, not that one, this one. It needs to do the mem copy thing. But we can do that later. We're not gonna need any of this right now, but yeah. So now we have moved it into program memory, and we have made it pretty transparent, or yeah, it's pretty hidden that we have moved it into program. We have a program block, but otherwise we are accessing them just as we did before. So if we now look here, these aren't here anymore. They are in the text section. Of course, this doesn't really matter for us right now because these are 5 and 7 bytes. But this prints out, this does a key press and key up. What we really want to do, and we haven't wrapped these yet. So in here we only have the USB keyboard press, but we also have the keyboard keys, keyboard modifier keys, and USB keyboard send functions. So what these would do is that we should update this keys array to hold the keys that we want to, that are pressed right now. And the same with the modifier keys. And then we do USB keyboard send. And doing that send should actually trigger like key down, key up, and do all of that stuff for us. So if we grab these and wrap them in here. So this is a procedure, USB keyboard send. It doesn't take anything and it returns an int 8, and it's an import called USB keyboard send. Now we also have and this needs to be a variable, uint 8. Yeah, so import C this as keyboard modifier keys, like this. So again, we don't really have to like nimify these identifiers. I just like to do it because it makes it a bit more obvious what's going on. And keyboard keys. Keyboard keys is also an import C of keyboard keys. Of course, I shouldn't have nimified this one. Or camel cased. And this is an array of 6 uint 8s. Oops. Missing a dot there. Right. And this does no decal and imports the header for us. So this should be fine. This, of course, is not uint 8. This is a key, an array of keys. And the modifier keys is obviously modifiers. But they are type compatible, so that's fine. Right. We need to export these. And export that. Right. So now we need to track this state. So we need to have 6 keys, convert that to an array, or set those in the array, and yeah. So I think we're going to use the built-in set for this. They should be an efficient bit set. So I'm gonna do keys is a set in the range from 0 to rows dot length times columns dot length. So that is all of our keys as numbered. So for example, this would be key 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. And of course, this is going to be nulled out for each iteration through this loop. Then, if this is set, we are going to include call times columns.length, no, times rows.length plus row. Oh, okay. And we're not going to do these anymore. So, yeah, that should work. Now, of course, we need our key map, which needs to be an array which has to hold 35 keys. And we are going to wrap this as well in a macro at some point. So I need 35 keys for this. You know what? I'm just gonna grab the first 35 keys from here. So assuming these are sequenced 35, we start at 4, so I need 4 more. Grab these. Let's just call this layout 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm not sure why I'm counting these, because these are the letters of the alphabet. 20, 21, 22, 23, 24, 25, wait, it's 26 keys in the English alphabet. 27, 28, 29, 30, 31, 32, 33, 34, 35. That should be 35 characters, hopefully. Right. So after we're done looping, we want to loop over the keys, and we want to set keyboard keys. Does this have a pairs iterator? Keyboard keys I equals key. No. Apparently it does not. So let's just do this. Right, just cast this to a key because we know it's a key. Oh, actually, we are going to do layout key. So now we have our layout defined up here. This is our key, our keys. We set the keys in here. If I is equal to 6, which means that we have inserted as many as we can, we just break. And down here we do USB keyboard send. We don't worry about modifiers just yet. And just discard that. Needs nym error flag. We have an error somewhere, which is really annoying because I don't know where. It might be that this just needs errors. In which case they will add way too much to our program size space thing. Does that generate the code? No. System module needs nym error flag. That means something in our code can throw an exception, and we are running in such a stripped down mode that we don't have exceptions. Whether or not we really need to is another. I think if we do OS any, that actually isn't an issue. Yeah, we have any down there. Yeah, but as you can see, our program size ballooned because we now need exception handling. So somewhere in here we have some kind of exception handling. Nym sep mem, nym zero mem, nym error flag. Right, set mem is apparently what's... Huh. So because our type... Wait, this uses 0 mem. Ah, yeah, this uses the same thing. So because this needs to be zeroed out every time, it can throw an exception. That is really annoying. What happens if I put this as a global? I mean, now it's not gonna... Yeah, still the same. Same overhead. Yeah, error flag stuff. It's a shame, really. Oh, but now it doesn't actually appear to ever check an error. Okay. Interesting. It might be... It might just be that the send... Yeah, because it might just need more of the sending stuff. Good night, by the way. Let's try to do something silly here. Right, that dropped it down up to about what we had before. So it's not the USB keyboard send that is doing the thing. Okay, so apparently sets will just add way too much overhead. So let's set these right in here. Keyboard keys I is equal to layout key. Layout column times row dot length plus row. Let's not do any of this. And we need to increase I. And I needs to be 0 out there. And oh. Yeah, so do that check here instead. We can't, I was about to add a block around this and break out of that block, but then these, since they reset the state after the loop, that would probably break. Because when we then jumped out of there, it would leave the pins in a weird state. Or it wouldn't reset them properly. Right. (2042 bytes), so still more, but not extremely much more, like in this case. So this is probably just because the send thing needs some more code. I'm not too worried about that. Let's see if this works. It might not. Hit the key. Right. So this should now print out. It won't print out A, B, C, D because I'm using a Dvorak keyboard. So this machine is set up to map QWERTY keys to a Dvorak layout. But each of these keys should now output at least a distinct key. Ooh. Ah, right. We don't clear our keyboard keys. Keyboard keys is equal to, actually just reset keyboard keys. Not sure if that may be, no, that didn't use a extreme amount of memory. So reset just resets a type to all zeros in them. Okay. Still haven't seen any repeat keys, so this looks good. And at some point here I am, 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. So that works as we expected it to. Again, the reason it's not printing A, B, C, D, E is because I'm using a Dvorak keyboard that thinks it's a QWERTY keyboard. So my computer is set up to do the QWERTY to Dvorak conversion. Right. This should also mean that we should be able to hold 2 keys. I mean, we should be able to hold the key. Yep. That works. We should be able to push 2 keys at once. It's kind of hard to verify that. I guess we could run I guess we could do this. So you see I got a key press and key release for the A key. So I should get key press, key release. Key press for A, key press for X, key release for X. I got a new key press for X, and a key release for X, and a key press for X, and a key release for A, and a key release for X. Oh. That was probably just the repeat thing. So if I try to generate some events, if I try to do like one of these, key press X, key press A, key release A, key release X, X, A, should have technically gotten the X release first. Right, yeah. That might just be because our we have this 2 millisecond delay, which is probably way too much. This was just to wait for this row to actually be pulled high. But 2 milliseconds is probably way more than we actually need for that to happen. Right, so now we technically have layout mapping. That is cool. There is one. This is part of the specification about what you should do with ghosting. We can set this to be like a ghosting thing. We also obviously need a way to send modifiers. Now, since we defined this to be keys and not keys and modifiers, since these are two separate enums, we can't put them in the same array. Of course, putting them in the same array earlier would have just made a mess. Like, I would have been able to do this, but that would have generated just a key press with how our code is now. So it's actually safer. It's actually a good thing that I'm not able to put modifiers into this array. Probably what we would do is generate, like, have one that's like, if it's a 0, go check if it's a modifier, and then have some modifier table somewhere. Something like that could work. Right. But yeah, that is I think we're gonna cut it there. We have started moving stuff into program memory. We have technically set up our first layout. We have done this layouts, like actually now reading and acting like a proper keyboard. This I could now technically type on this. Like, I can do something like this. I could, like, oh, you can see that there. I could do something like, hello, world. I mean, I can pretend that this is a keyboard. Actually, what is this key? That is 3. Let me bind 3 to is it, what is escape here? Ah, backspace is what I wanted. So if you do this, just to sort of show that it now works as a proper keyboard. I can do, oops, I was in the wrong window. I can do hello, and it works as a keyboard. Cool. Yeah, so this took a bit longer than I was expecting to. This progmem stuff used to be easy before the NIM compiler introduced that bug. I am going to try and see if we can fast track fixing that. Otherwise, we will just have to keep using this custom compiler. This obviously means that the code that I'm now going to push to GitHub requires that custom compiler fix, which isn't great. But yeah. Oh, and one thing, I actually forgot to mention this. I meant to mention this in the beginning. At the end, or when we wrote this read pin function in episode 3, I said that this is going to be overridden by with pin as, but now you can see I have row dot read pin, and if we look in the teensy code here, this read pin, I have sort of done a cheeky little thing. I have created a type, which is iter var type, which is just a random symbol. I have just given it a random type, in this case an int, and I say iter var. Oh, it's not a random type. So iter var is the iteration, the count, so call or row in our code. In our code here, this is iter var and this is iter var. But yeah, we have a type wrapper over ints, and this read pin takes an argument that it doesn't use that has this type. So this will apply to this one iterator loop thing, which is pretty cool when you think about it. Like this read pin, even though it just expands to this generate read statement case macro or case template, this read pin thing only works with this specific int, but it's just an int. It's not on runtime, it's just an int. But since all of this is expanded on compile time, that doesn't matter because it knows, NIMS knows to pick the correct read pin implementation, which I think is pretty cool. Oops. So yeah, now we do row read pin, and we can do call read pin, and it would use the read pin template that it defined up here. It still defines a read pin even though this is output. But I mean, we could set it up so that if it sets it as an output, it doesn't create a read pin template. But it should be fine for now. Yeah. As I said, I think we're gonna cut it there for today. Next time, we're probably gonna do, as I said, layout, create a nice DSL. I know I said we were gonna do this for this episode, but this progmem stuff just took way longer than I expected. We're gonna make a nice DSL for the layouts, and probably we're gonna create some nicer code for this, I think. Like I think we're gonna define layouts in such a way that you can do something like, yeah, something cool. So that should be fun, so that users don't have to track this I and reset the keyboard keys and all of this logic. Just hide it away. And of course the layouts will support like modifier keys and whatnot. Yeah, that is it for right now. I'm gonna obviously push this to GitHub. It won't work unless you patch the compiler. Yeah, hopefully this episode should be easier to edit because I have been adding sort of bookmarks into it, and I have stored every time someone says something, and I have stored every time I do transitions. So this video should hopefully be way easier to edit than the other ones have. Yeah, that's it for me for today. Hope you enjoyed the stream. Goodbye.